Okay, so I'm going to briefly discuss the regulation of the complement system. It's very detailed, and I will talk in another video about the 3 different cascades of the complement system: the alternative pathway, the MV-lectin pathway, and the classical pathway. All these pathways do different things. For instance, the classical does antigen-antibody complexes. Alternative takes place on pathogen surfaces. They all do different things, and but what's important is that they can be damaging. The whole complement system can be damaging to many hosts, or host tissues. So the activation has to be tightly regulated, just in case something goes bad. What regulates this system is called the complement control proteins. There are many different types, tons of different proteins that play a part in this system or in the regulation. Some complement control proteins are on the membranes of cells, preventing them to be targeted from complement. An example of a protein is CD59. This is called protectin. It inhibits C9 polymerization during the formation of the membrane attack complex, or the MAC, the MAC. The classical pathway, which is one I talked about a minute ago, is inhibited by the C1 inhibitor. This binds to the C1 to prevent the activation of that. And then we have a C3 convertase that can be inhibited by DAF, which is the decay accelerating factor. So those are some examples of some of the proteins that play a part in this. The activity of some of these proteins is species specific, so depending on what's being done is depending on what protein will take place in the activity. I also have a list of some key regulators of the complement system. I can't memorize these, but they are some of the important ones that I picked out that I thought were worth mentioning. Key regulatory proteins. So here's a few of them. The C1 inhibitor, which I talked about. What this does functionality-wise is it promotes the dissociation of the C1R2S2 from C1Q. And that takes place in the classical pathway. The C4BP protein blocks formation of C3 convertase in the classical pathway. Factor H is another one. It blocks formation of C3 convertase in the alternative pathway. And then the membrane cofactor protein, which is the CD46, is cell-bound, and it blocks C3 convertase in the classical and alternative pathway. And then you have the DAF, which is I talked about, the decay accelerating factor. It's membrane anchored, and it promotes dissociation of the C3 convertase from both classical and alternative pathways. So those are some of the key regulators of the complement system, even though there are more. I just wanted to list a few of those. So without this complement system, or the regulatory of the system, a lot of stuff could go wrong. So it's very important that we have this system. Like I said, there's many different proteins that do many different things depending on what is being done and what needs to be done.